Slope-intercept form is the function form of a line. So we use that a lot. And you likely know how to use it already. But I'm going to go ahead and just make sure that we have a little refresher. And then hopefully you understand why it works, which is important too. So first off, just the names here. M is the slope and B is the y-intercept. Well, before we actually use that, it would be kind of nice to understand why it's the slope and why it's the y-intercept. So to do that, we're going to look at a couple little details here. First off, we're going to look at the parent function of this. So the parent function is just the function that kind of has the least amount of changes. So the slope is just 1 over 1, kind of just a neutral speed. And the y-intercept is just 0. It goes right through the origin. I'm just putting that there so we can compare it, but just think of it this way in that the parent function has a change in y of 1, and it has a change in x of 1. So its speed in both the x and y direction is 1. There is a mathematical reason for that, but frankly, whenever I've tried to explain it, I think it just gets a little too complicated. So take my word for it, and you can look up an explanation somewhere else if you're interested. Now let's look at an actual example and see what happens when we mess with some of those values. All right, so I already mentioned the fact that this 2 here is going to be our y-intercept. Well, I would also keep in mind that the y-intercept is really just a point, and that point has 2 coordinates. Well, since it's on the y-axis, I automatically know that my x value is going to be 0. Well, that's interesting. Now, let's assume for a second that we don't actually know that this is it too. And if you're not sure what I mean by this, just think of any point that's on here. All of them are going to be like, this is 0, -3. Because if we start here at 0, 0, and we travel to the left or right, okay, that's going to change our x value, our x location. If we're on the y-axis here, we haven't traveled to the left or right. So if I want to find my y-intercept, I actually already have a piece of information. We already know that the x value is 0. It's going to be 0, something. And so if we take this example here, we can write in y equals -5/3 times 0 plus 2. And so if it's in this form, this term right here is always going to drop out. And so we get y equals 2. And so instead of doing all this work every time, as long as it's in slope-intercept form, we know that this constant right here is going to be our y-intercept. Cool. So that gives us a starting point there. And then the slope is going to tell us the directions. And without getting into too much detail here, the idea is that this top term here is going to make us go 5 times faster in the y direction. So looking at our parent function, we normally go up 1 and over 1. Well, in this case, we're going to go 5 times faster in our y direction. So we're going up 1, 2, 3, 4, 5 in our y direction. And then that negative, I do have to apply that to one of them, so I'll apply it to the x there. So I'm here, and then I'm going to go 3 times faster in my y direction, or x direction. 1, 2, 3. Here we go. Now, one of the things that you'll notice I almost did in this particular case was I almost, and that's a really terrible looking line, but oh well, is I almost went in the other direction. And that's one of the other things that you always want to keep in mind is that this does have a negative slope. That means that as x is increasing, y has to be decreasing. So if you notice here, I get a positive versus a negative reaction if I'm going in this direction. I could also go in the other direction, kind of how we set this up, and then I'm going positive in the y direction, but I'm going negative in the x direction. And if you combine those together as a quotient, well, a positive divided by a negative or vice versa is always going to be negative, giving us that negative slope. Again, you can see that as I travel to the right, I'm traveling down. That's my negative slope. And that's just a quick example, a quick refresher on slope-intercept form and why it kind of works.